Welcome to another video of 30-day LeetCode challenge. So today's question is something like this. You're given a binary array and you need to find the maximum length of a contiguous subarray with equal number of 0 and 1. Obviously, binary array means the values will either be 0 or 1. So given an example like 0 comma 1, we know the length is 2 because the count of 0 is 1 and count of 1 is 1. Similarly, in the second example, we see count if we take the contiguous subarray from index 0 till 1, it has equal number of zeros. And similarly, if we can consider a subarray from 1 to 2, because this region will have equal number of zeros and 1. So let's look at the approach which we can take. Ideally, uh, this quotients, like let's say 0 comma 1 comma 0, right? I would basically make possible subarrays. So let's say the index is 0 1 2. So my possible subarrays will be let's say 0 comma 1, 0 comma 2, and 1 comma 2, right? These are the possible subarrays of this. So but the overall time which it would take would be O of n square in order to generate all the subarrays and then check the count of zeros and one in each subarray. um we could do this, but the given constraint is uh, n value can go up to 50k. So I doubt n square is gonna work, and it might give us time limit exceeded. We might need to take a different approach here. um, One way would be, we know, so obviously it's going to be a linear solution. um, One way would be, let's say I am at index 0. I know the count of, okay, let's see, I keep count of zeros and ones. So at index 0, my count of 0 is 1. This is 0, right? And then at index 1, my count of 0 becomes 1, 1 becomes 1. So this becomes balanced. uh, and then in the next case, the count of 0 becomes 2, count of 1 stays at 1, so this becomes unbalanced. So let's say I have a count. So in this case, my count, if I just total this is 1, this is 2, this is 3. It doesn't give any significance. Let's say I have -1 for 0 and 1 for 1. So I add -1 if I come across a 0, and I add 1 if I come across a 1. So my count right now here will be -1, right? Because I have 0 as 1 and 1 as 0. Similarly, next index, so I'll say that this is index 0 1, it's index 2. So now at index 1, my count becomes, this is -1 and this is +1, so it becomes 0. And then here my 0 is -2, so it becomes -1 again. So what do we see here? If we represent 0 as -1 and 1 as 1, and we add it to the count moving forward, we see that when we get a 0, we know for sure it's balanced in the sense the number of zeros equal to number of 1. So obviously we can consider those indexes. So obviously this index is 1, so because we are dealing with index, I can just add +1 to the index, and that will give me 2, which is 2 is the maximum length of the contiguous subarray having equal number of zeros in it. So this is the one way to solve it. What else? Let's think about corner cases, because there will be scenarios we won't get 0, right? Let me take a new page here. Let's say I have a scenario like this: 0 0 0 0 1 0 0. So in this case, my solution should be this. right? This part. Let me give indexes as 0, 1, 2, 3, 4, 5, and 6. 0, 1, 2, 3, 4, 5, 6. Correct. So here, if I keep a count, at 0 it becomes -1, because as I said, I'm gonna represent 0 with -1 and 1 with 1. Here it becomes -2, here it becomes -3, -4. Now here it becomes -3. Obviously here it becomes -4, and it becomes -4, right? So what are the evident values here? This is common value. So let's see, this is repeated, this is repeated, similarly it repeated here and it repeated here, right? What do we see? One thing is, when it's -3 here, and we got a -3 here again, we know for sure that something in between this index 2 and index 4 balanced it out, right? So something happened between these two indexes that balanced it out, and that's why we got the same value here and here again. So that be, so balancing out, it will happen only when there has been equal number of zeros and ones. So we have index 4 -3 and index 2 at minus at 2. So what we can do, we can be sure, if I do 4 minus 2, the length of the subcontiguous subarray is 2, and I can be sure that because this occurred twice, uh, this region, which is between 2 and 4, which is like basically index 2 is on a circle and 4 is on a square. Similarly, we see, I'll take a different case, right? So we see -4 has occurred twice, right? So I can be sure that this region is again balanced, right? So this region will be like 4 closed, comma 5 closed, or open 3, comma 5 closed, right? So I do 5 minus 3 and I get 2. So what do I see here is, if any value, so I can keep a map, right? Or I can store it somewhere, and I can keep this count value mapped to index, which is -3 mapped to index 2. Now when I come across a -3 again at 4, I know for sure, because it has appeared before, it's the end of that balance. So the balancing started from -3 index 2 and it end at 4. So I can be sure that I just need to fetch this index and my current index, and I just subtract it and I get the maximum length. So it's all about, I think it's all about balancing here. Like we see the balance of zeros and ones, so we represent zeros with -1 and 1 with 1, and I just keep a count. So because this, so let's say if there was no 1 and there were all 0, right? So this was a 0, obviously it would have been an incremental -3 -4 -5 -6 -7. We will never see a balance or a repeated variable. It's just that because of 1 we get the value, we add a 1, right, to a minus value, so it gets added and it gets balanced. So that's the reason we can be sure that between these two regions there were equal number of zeros and 1. That's why the number got repeated. If this explanation was clear, we can go to the implementation. So as I said, I can keep a count, I can keep a map of, I do so if I come across count to be 0, I simply take the max length to be the index, right? Because 0 means the array started at 0, and because my current count became 0 somewhere in middle, I'm pretty sure that it had been balanced out. But because of this minus, the last example we saw, we are gonna consider these cases as well. So there are two cases to consider. So if nums of I equals to 0, okay, and then I plus 1, yeah. And so we find it in the map, then my max length will be equal to max of max length, comma, find the map, find. So I do index I minus. Okay, my bad, spelling mistake. Let's see. Okay, awesome. I guess this question was clear and it was fun to solve this one. If you guys liked it, please subscribe to my channel and don't forget to give me a thumbs up. Thanks everyone.